All right, data analysts. Today, I'm going to be giving you an overview of how to do the T2 exam practice, our day 2. So it looks like there's a good number of people who have already turned this in. That's great. If you've not turned this in, then you need to make sure that first you try this on your own. If you run into any problems, then you can watch this video, and I'll take you step by step through how to do this entire exercise. Now, as you're doing this, I would recommend taking notes because remember, our T2 exam is open notes. So without further ado, let's go ahead and get started. Now, I'm going to do something a little bit different than what the directions say because I want to give everybody an idea if they're still confused on how to do the setup of installing the right packages. I want to give you that overview for how to do that because that's what you're going to have to do on your T2 exam. So let's go ahead and start by creating a new project. And remember, this takes a little bit of time, so don't worry about that, but it'll take some time to get this. And once we do have this new project created, remember, it's like a brand new computer. So those libraries that we've been using before, those packages that we have been using before, they're not actually installed in this project. So that's going to be the first thing that we need to do. And when you're doing your final exam, that's going to be the first thing that you're going to have to do. So now that we've got our new project, notice how we do not have an R script. Okay, we have to create a new R script, but we don't even need to do that to install a package because when you're installing packages, you do that in this console. So let's start by installing the first package, which is the readr, and this allows us to take a CSV file, a comma separated list of values, and turn it into a data frame in R. So this is going to take a couple minutes to download. Alright, so you know the installation process is done when you see that blue arrow with your cursor blinking. So that's the first package we need to install. There's one more package that we need to install, and that is the ggplot2 package. So again, we need to make sure you put that in quotation marks there, and it kind of prompted me to do that. But make sure you have that in quotations, just like we had the readr, and we'll go ahead and install that package as well. Alright, so again, we are looking for that blue arrow and our blinking cursor, so we know that we're ready to go. And now we've got these packages installed so we can use them in any R script that's in this project. So let's go ahead and start by creating a new R script file. And then the first thing we want to do is we want to actually load these libraries into the R script. So to do that, we use the library function. And then the first one we had is the readr. Notice how I do not use any quotation marks when we're calling the library. And then make sure you run this, so Control Enter, so you should see library readr, to make sure that now your console knows that there are these additional functions that you can use. We'll do the same thing, library in ggplot2, again, Control Enter, make sure you see library ggplot2 getting sent to your console so that the console now knows that it has some additional functions that it can use. Okay, so we have the setup process done. Now we just need to get the data loaded into this R script. So we'll start by downloading the file. So to do that, we'll have to open in a new window and then download. So you'll see that download there. And you can go back to your RStudio. And we need to upload this first. So we'll choose the file from our downloads. Netflix is the name. And then now that we have it in our files, we can actually import it into, and we have the library functions all ready to go. Now we can go ahead and import this as a new object. So we will call this object Netflix because that's what it says in the directions. Netflix. And remember, to assign values to that, you need to use the assignment operator. And then the function that we're going to use to read this CSV file is the read.csv, and we need to use in quotation marks the exact name of the CSV file that we see in our files. So netflix.csv, and when we run this, we should see that a new object is created, and there we are. So we can see that there's 7,787 observations of 10 variables. So basically we have 7,787 either movies or TV shows, and we have 10 different data points about those TV shows. Okay, cool. So now let's get into doing some of the analysis. So we've done all this setup part. The first step that we actually want to do is we want to view the variables and the first few elements in each of the columns to determine the types of variables that we're dealing with. Remember, when we're creating visualizations, there's a difference between quantitative variables and categorical variables. So we can only create certain charts for quantitative variables, same thing with categorical variables. So let's get a view of these different variables by using the head function. And we will put in the name of the data set that we're trying to learn more about, which is Netflix. So we'll run that, and let's see what we got. So one of the variables is show ID. The next variable is the show type, the title, and we've got the director. We've got the country that it was filmed in, the date that it was added, the year that it was released. So Netflix does have some old TV shows on here. So they were released maybe in like 2008, but they didn't show up on Netflix until January of 2020. We have the rating, which is kind of interesting. We'll be able to see, like, does Netflix have a bunch of dirty shows, or they have a bunch of kids content? Where's the majority of their content? See the duration, so how long are each of the episodes or the seasons? And then it looks like the last thing we have is listed in. So that is the different categories that that movie or TV show falls into. So lots of good information here. We can see that some of these are going to be quantitative variables, some of these are going to be categorical variables, and we can do different visualizations based on that fact. So the next step that the directions tell you to do is to create a one-way table to display the number of shows or movies that have a particular rating. Well, if we think about this, particular rating, that's a categorical variable. That's a category that each of these movies could be put into. So are they rated R? Are they rated PG-13? Are they rated, if it's a TV show, is it TVMA? Or is it TVG? Or whatever. So we can figure this out relatively easily by using a one-way table. So to do that, we will create a table by using the table function. And then the first thing we need to put in as an argument is the name of the data set. So in this case, it's Netflix, and then a money sign, and then the variable that we're trying to create the one-way table for. So in this case, the variable is rating that we're trying to show. And when we run this, we can see the number of films that fall under each rating. Okay, so you can see there are movie ratings. So like these are all G, NC-17, NR, PG, PG-13, R. These are all movie ratings. And then the TV, these are TV show ratings. So if a show is on TV, it gets one of the TV ratings. If a show is like in a movie theater, or is created to be a movie, then it has one of these movies or ratings. So it's kind of interesting. It looks like if we're just comparing, the R-rated movies to the G-rated movies, these are like the kids' movies, and these are like the ones we're not supposed to watch unless you're 17. Like there's a lot more R-rated movies than there are G movies. And then it probably has something to do with people who are paying for Netflix, right? A bunch of kids don't have a ton of money to pay for Netflix. Adults, they do have money because they have jobs. So Netflix is catering their content to their customers. But it does look like they have a fair number of TV-14, so this would be like right in the middle, TV shows. But again, if we're looking at TV shows even, there's more TVMA. This is like the bad ratings, the dirtier Netflix shows than they do the TV-14. Probably, again, because you got to think about who their customers are and who's paying for their content. And if they had a whole bunch of kid stuff, then they wouldn't be able to have as many customers. All right, so let's go ahead on to the next step, which is to create a proper visualization for the rating variable. So we want to show how many either TV shows or movies have each of these different ratings, and we want to show that visually. So to do that, we need to create a bar graph. Remember, bar graphs show categorical data. That's what we have here. We have categorical data, so we need to create a bar graph. So to do that, ggplot is what we're going to start with. And then we need to first give the name of the data. So that is Netflix. And then comma, AES, so we're giving it some aesthetics. So we're saying the X variable is going to be rating. And then the other things that we need to do are add some geometry. So because this is a bar graph, we need to add the geom bar. And we also need to add in a title. So gg title is the function for that. Remember, when you're giving any titles or labels, you need to put them in quotation marks. So this would be Netflix shows and movies by rating. In addition to the GG title, we also want to add an X label to show what's on our X axis. So in this case, our X lab is going to be the rating. If we do that correctly, we should get a nice little bar graph that visually shows us the number of Netflix either shows or movies that have specific ratings. So you can see that there's a ton of these TVMAs, like lots of episodes, lots of TV shows that are rated TVMA. So compared to like R-rated movies, it looks like Netflix has a lot more TV shows than movies, which is kind of interesting. I didn't really think that. I thought that they were like a big movie kind of thing. But I guess that actually kind of makes sense because a lot of people do talk about how like they're watching seasons of an episode. So, but also if you're thinking about kids content, there isn't a ton of it, right? Like, I mean, if we're looking at TVG, if we're looking at the PG and the G rate, I mean, there's not a lot of kids content compared to the adult content. So Netflix is definitely catering to the people who have the money, the people who can afford to pay that monthly subscription. Okay, so let's go ahead and move on to the next part. In the next part, we wanted to get a summary of the variable release year. Now, year, that's a number, that's quantitative. So we can actually find the average, we can find the max, we can find the minimum, we can find the first quartile, we can find the third quartile. And we can do that by using the summary function. So we're going to use summary, and then we need to give the name of the data set first, so Netflix. And then money sign, and then the release year is what we are trying to create a summary of. If we run that, we can see that, so the earliest year that a Netflix show was released was 1925. So the oldest movie they have was actually released in 1925, so way before I was born. And their most recent movie was released in 2021. And that makes sense. I mean, they're releasing new stuff all the time. If we look at the average year is 2014. Okay, I guess that kind of makes sense. So it means that they have, you know, probably a lot more newer content, but there is some of this older content that's in there. You can see that the majority of our release years are between, so the middle 50% are between 2013 and 2018. So really, content is focused more on the more recent, and that's what people want to watch. They don't want to watch old stuff. Maybe there's a couple things that are old that they want. But people want to watch stuff that's related to what's going on in the world nowadays. So it's stuff that's being created now, not, 50 years ago. All right, so let's go ahead, and the next thing it says is in a comment, write the oldest released year of a movie or show on Netflix. And so, like I said, Netflix doesn't just create their own content; they also purchase old movies and TV shows. And so, yeah, even though there's a movie that was released in 1925, Netflix didn't create that. They just bought it, and then they put it on their platform. So if I want to make a comment, remember, comments start with the pound sign or the hashtag, and then we just need to say the oldest Netflix show / movie was released in 1925. So wow, 1925. I don't even know I wonder what show it was or what movie it was. But it must still be like kind of popular because if it's on Netflix, like people are watching it. All right, that's cool. So we can go ahead then and move on to the next step here, which is step 9, where it wants us to create a one-way table to show how many Netflix shows were released by year. So we want to see, okay, how many were released in 1925 versus how many were released in 2002 versus how many were released in 2021. We can kind of assume based on the summary statistics that the majority of our Netflix shows were going to be released somewhere between 2013 and 2018. But let's see exactly. So to create this one-way table, we do it the exact same way we created the one-way table for our categorical data. So we're going to do table, Netflix. This time, though, we're not doing the rating variable, we are doing the release year. And this will show us, by year, how many were released. So you can see that this one-way table is a lot bigger because there's a lot more quantitative data points that could show up. When we're talking about ratings, there's only so many different ratings that you could possibly have. When you have shows that were released all the way from 1925 to 2021, there's a lot of years where these shows could be released. But just like what we kind of expected, if we look, there's very few shows or movies that were released a long time ago. So 1960s, there's like 4, 3, but as we get closer and closer to where we're at right now in the 2000s, and specifically when we get to that Q3, we can see that, whoa, yeah, this is where the majority of the shows are. And even more recently in 2019 and 2020, probably slowed down a little bit because of COVID. But yeah, it looks like the majority of the shows were released between 2013 and 2018. And obviously this is probably going to move as Netflix releases more content and more people get subscribed to it. But that's what we're looking at right now. So we can see that in 2018, Netflix released 1,121 shows. Or Netflix has 1,121 either shows or movies that were created or released in 2018. And I think that's the next thing that we need to do here. So it says in a comment, write the year and how many movies or TV shows were released in that year. So if we wanted to talk about the year where they had the most TV shows released, we would be saying that 2018 it looks like. So again, to make a comment, we do the # or the hashtag, and we will say, in the year 2018, Netflix has 1,121 shows / movies that were released in 2018. So if you're a fan of 2018, Netflix is your spot because there is a ton of content that was created in 2018 that you can view on Netflix. All right, so I believe there's one more thing that we need to do in here, and that is to create the appropriate visualization for this release year data. So as we previously talked about, because this year is quantitative data, we need a histogram to display that. So to do that, hist is our function. We're going to go ahead and open parentheses, give it first the name of the data set, so Netflix. Because we're not doing ggplot, we're using the hist function, we're actually going to give the specific variable by using the money sign and the name of the variable. So hist, Netflix, money sign, release year, and then comma. We need to add in the appropriate main title and X label. So main equals, and in quotes, so this is going to be Netflix shows by release year. And then we need to give also an X label. And in this case, our X label is going to be the release year. All right, so if we run this, we can see, yep, this pretty much makes sense. We saw that there were very few that were released in 1930, but as we get to more recent times, especially in the 2000s, Netflix has a lot more shows that were created. And that makes sense again because people don't want to watch old content all the time. They want to watch new stuff that has current events, that has current trends and things that are going on in the shows. Okay, so notice how we included the proper X label and the title, and then we can see that the Y label is always given to us as frequency. Whenever we're creating a bar graph or a histogram, that Y label will always be either the frequency or the count. Okay, So the last things that we need to do are to knit the document into a PDF and then submit it to Google Classroom. So to knit the document, I need to first check and make sure that all of my things are working. So when I run these all should work. I've ran mine as I go, so I know that it's all good. But then the next thing would be to do File, Knit Document. We need to give it a name, so we'll call this T2 Exam Practice _ Day 2. Save that, and then it's going to prompt you to download some of these packages that are necessary to do the knitting. So yes, we want to install these packages. This will take a couple minutes. Remember, when you see this cursor flicking or blinking next to the blue arrow, you'll know that you're ready to go. And now we can choose the output that we want. So we do not want HTML, we want PDF. We're going to go ahead and compile it. And this is what we should have. So you can see that it has all of our code that we wrote. But then it also has the output from the console. So when we did head, this was the output that our console gave us. When we did a table, this is the output that our function gave us. When we ran this ggplot, this is the graph that was given to us. When we did the summary, this was the data that we got. You can see all the comments. When you use the pound sign, they all show up in gold, so they're easy to read. There's our table and the output. Comment, nice and gold. And then the last line of code here, our histogram, which actually created the histogram. Alright, so I'm going to go ahead and download this. Make sure that this is saved. And you might want to rename it once you've downloaded it. But this is going to be the document that you will submit for the homework assignment. And you're going to do the exact same thing on your exam. Alright, hopefully this helped. If you have any questions, please reach out to me via email. Otherwise, I will see you on March 3rd at 10 a.m. for your data analytics exam.